Hi students, welcome to our physics class now. So in this class we are going to learn about a refraction at a spherical surfaces in the ray optics topic, and also it is a topic in refraction of light at curved surfaces in 10th class physical science, and in 10 plus 2 intermediate second year ray optics topic. So in this case, that is refraction at spherical surfaces topic, we are going to derive the formula n2 by v minus n1 by u is equals to n2 minus n1 by r. That is when the light is refracted through the curved surfaces of the denser medium. So how can we derive that formula? So students, so here this part, it is the denser medium. It is the denser medium which has a spherical surface, that is a convex surface. It is a convex surface. Now it is its optic center P. Now OPI is the principal axis. Principal axis. So consider O is the object from which a ray, that is incident ray, it is incident on the convex surface of this denser medium at the point A. Then it is refracted and meets the principal axis here where image is formed. This is a real image. Now from this dotted line is drawn, which is a normal line. So this is called normal, which is useful for measuring angle of incidence and angle of refraction. So here this incident ray and normal, between them angle is theta 1 is there. This is called angle of incidence. This is the refracted ray. So angle between this normal line, that is a C normal line, and refracted ray is angle of refraction theta 1. So from the figure, outside this convex surface of the denser medium, it is a rarer medium whose refractive index n1, and its a denser medium dm, its refractive index is n2, and po is the object distance from sign convention minus u, and pi image distance, that is a real image. So for this real image distance on the right side, that is plus v, and pc distance from optic center to center of curvature, that is radius. So now angle between incident ray and the principal axis is alpha, and also the normal line and principal axis are separated by angle beta, and the refracted ray is making some angle with the principal axis. This is denoted by gamma. So these are the angles. So angle between incident ray and principal axis alpha, and also a normal line and the principal axis beta, refracted ray and the principal axis is gamma. Theta 1 is angle of incidence and theta 2. So theta 1 is angle of incidence, theta 2 is angle of refraction, and alpha, beta, gamma are the angles so which are made by the incident ray and principal axis, normal and principal axis, refracted ray and principal axis. Now, so from the triangle we are taking AOC or COA. This is, we are taking triangle. From triangle OAC, you can see in OAC, inside this triangle angles are alpha and beta, outside this one is theta 1. So theta 1 is angle of incidence. So from the mathematics basics, in a triangle exterior angle equal to sum of two interior angles. Exterior angle is theta 1, sum of interior angles are alpha and beta, sum means plus, so alpha plus beta, theta 1 is alpha plus beta. Next we are taking a triangle ACI. We are taking a triangle ACI. So from triangle ACI, This implies in the ACI you can see students, exterior angle is outside this triangle. Exterior is beta, interior as gamma and theta 2. So beta is equals to theta 2 plus gamma. This implies theta 2 is equals to beta minus gamma. So now we derived the formula for angle of incidence theta 1. Theta 2 is beta minus gamma. So now from Snell's law we know that students, from Snell's law we know that sin I by sin r is equals to n2 by n1. This implies I means angle of incidence. Angle of incidence, that is I is theta 1. Angle of refraction is theta 2. So sin theta 1 by sin theta 2 is equals to n2 by n1. By the cross multiplication students, n1 sin theta 1 is equals to n2 sin theta 2. But we already derived the formula for theta 1 and theta 2. So sin of alpha plus beta is equals to n2 sin of beta minus gamma. But when the rays, when the incident ray is incident like that, so from the point A here students, from the point A to principal axis a normal is drawn. This normal is coinciding the point P. So like that. Now it is the incident ray. When the incident ray is incident on the convex surface of the denser medium, so like that, then alpha, beta, gamma will be very very small. So then we can take sin of alpha. In such cases, incident ray will be in the rays. The incident ray will be called paraxial ray. Refracted ray will be called paraxial ray. So at paraxial rays, so we can take sin of alpha plus beta is equals to alpha plus beta. Sin of beta minus gamma also equal to beta minus gamma. That is, when the incident ray is moving very close to optic center, then angle between the incident ray and principal axis alpha will be small, beta will be small, and the gamma will be small. In such cases, the incident ray and refracted ray can be called paraxial rays. So in the case of paraxial rays, we can take sin of alpha plus beta is equals to alpha plus beta. We can neglect sin because the angles are very small. Beta minus gamma, so also equal to beta minus gamma. So that is why in the place of this we can neglect sin. So it's n1 alpha plus beta is equals to n2 alpha n2 beta minus gamma. So now multiplying with n1 alpha plus n1 beta is equals to n2 beta minus n2 gamma. So this implies we are changing n1 n2 beta from right side of equal sign into left side. N1 alpha minus n2 beta, that is n1 alpha. We are bringing this n2 gamma from right side of equal sign into left side, that is n1 alpha plus n2 gamma equal to n2 beta, and we are changing from left side, that is n1 beta, into right side minus n1 beta. So it is the equation which is useful to derive this formula. So here students, minus n2 gamma is transferred to left side of equal sign. So n1 plus n1 alpha plus n2 gamma equal to n2 beta. This n1 beta is transferred to this side, that is plus n1 beta becomes minus n1 beta. So now using this one, how can we derive the formula? How can we derive the formula using this? Students, already we said from the point A to principal axis, a straight line, that is a normal line, a perpendicular line is drawn, which is also coinciding P. So now from the triangle, POA, we are taking tan alpha. POA. So tan alpha is nothing but formula from trigonometry, tan theta in a right angle triangle. Opposite side to this angle by adjacent side, that is opposite side to alpha by adjacent side to alpha. This implies tan alpha equal to opposite side to alpha, students, that is this side AP, and adjacent side is this will be hypotenuse PO. But we said rays are paraxial rays, then we can take tan alpha equal to alpha. So this implies alpha is equals to AP by PO. As the rays are paraxial means angle between incident ray and principal axis alpha is a small, and also angle between this is normal and principal axis beta will be small, and this is also very small. That is why you can take tan alpha equal to alpha, tan beta equal to beta, tan gamma equal to gamma. So now we are taking another triangle. From the triangle, in this case PAC, from the triangle PAC, this implies a tan beta is equals to opposite side to beta by adjacent side to beta. Opposite side to beta means AP ma, and adjacent side is PC. So, but you know, as the rays are paraxial rays, you can take tan beta equal to beta. This implies beta equal to AP by PC. Similarly, from triangle we are taking PAI. This implies tan gamma is equals to again opposite to gamma by adjacent side. Opposite to gamma means AP, adjacent side is PI. This implies gamma also equal to AP by PI. So now we are going to substitute expressions of alpha, beta, gamma in this equation. This implies N1 of alpha means AP by PO, students, plus N2 gamma means AP by PI is equals to N2 beta means AP by PC minus N2 beta means AP by PC. Students, just alpha, beta, gamma expressions are substituted. So in this expression, so now in this expression AP is a common quantity, so this implies you can take out this one as a common quantity, N1 by PO plus N2 by PI is equals to, here also AP is a common, N2 by PC minus N2 by PC, N1 sorry, not N2, this is N1, students, N1 this is N1 by PC. AP get cancelled. PO, you know object distance minus U. So minus N1 by U plus N2. PI means plus V, that is image distance. For real image distance is plus V equal to N2 by PC means radius R minus N1 by R. So this it can be written as, students, minus N1 by U minus N1 by U, it can be written as minus N1 U plus N2 by V means N2 by V minus N1 by U is equals to N2 minus N1 by R. N2 minus N1 by R. So this is the derivation of the formula, that is n2 by v minus n1 by u is equals to n2 minus n1 by r, that is a refraction at spherical surfaces, students. So now suppose we are taking a plane surface. Suppose in the place of this convex spherical surface, suppose we are taking the surface is a plane. But how can we apply this formula in the case of plane surface? So when the refracting surface is a plane, so we are applying this formula, applying this formula for plane surface, which is a refracting surface. But for plane surface radius is infinity, students, then n2 by v minus n1 by u is equals to n2 minus n1 by r, means here we want to take infinity. This implies n2 by v minus n1 by u is equals to 0. Then n2 by v is equals to n1 by u. So when the refracting surface is not curved, when it is a plane, so this formula we use. It is a special case. It is a special case, students. But that is the derivation of the topic. n2 by v minus n1 by u is equals to n2 minus n1 by r. That's all, students.